Hello everyone, welcome to the next Math Short Trick Masterclass. In this class, I will tell you how to find the unit digit of any number raised to power massive power by using cyclicity trick. So look at the cyclicity table first of all of every numbers. So any number whose base is, let's say, 0, 1 or 5 or 6, the cyclicity of this number is 1. So what is the meaning of cyclicity? For example, 1 raised to, if you take any power, let's say 50, the answer is 1. Okay. So if you take any power to be 1 raised to power any number, the answer will give you in the end 1. So unit digit is 1. Similarly, 5 to the power, let's say 5 raised to 1, that is 5. What is 5 square? 25. So last digit is 5. Similarly, if you do the 5 raised to 3, so ultimately you'll get last digit is end up with 5 only. Similarly, in case of 6, if you raise any power of 6, let's say 6 raised to 49, the last digit will be 6 only. So that means the cyclicity of all this number 1, 5, 6 is 1. Then the number 4 and 9. Okay, so 4 raised to 1, which is 4. 4 raised to 2, which is 16. So last digit is 6. Now if you multiply 4 raised to 3, so if you multiply this 6 with 4, you'll get last digit is again 4. So these numbers repeat 4, 6, 4, 6, 4, 6 in the end. Okay, so the cyclicity of digit 4 as well as cyclicity of 9 is nothing but 2. Okay, so we have one short trick here. 4 to the power any odd number is there, then the answer of the unit digit is 4. If 4 raised to any even number is there, then the last digit means unit digit of that number is 6. Similarly, 9 to the power any odd number, then the unit digit of that number is 9, and 9 to the power even number is there. In that case, our unit digit is 1. So remember this trick. Now the remaining number 2, 3, 7 and 8. Okay, for example, any number like that 2 raised to, you have to calculate 2 raised to 2025. Okay, so base is here 2. So first of all, you have to learn what is the cyclicity of 2. So cyclicity of 2 means which digits will come when you raise the power of 2. So 2 raised to 2, which is 2, then 2 raised to 2, that is 4, then 2 raised to 3, which is 8, then 2 raised to 4, which is 16, so last digit is 6. Then when you take 2 raised to 5, it becomes 32, so last digit is 2. Okay, so last digit is 2, 4, 8, and after that 6. After that, when we take the raised to power 5, the last digit is repeating. So the cyclicity is 2, 4, 8, 6. That means cyclicity has 4 elements. 2, 4, 8, 6. Only this number will repeat when you raise the power of 2. So cyclicity of 2 is nothing but 4. Similarly, cyclicity of 3, which is 4, and 7 and 8 also, cyclicity is 4. So whenever the base number is 2, 3, 7 and 8, our cyclicity is 4. Okay. So these are the number. Now the important thing is, whatever power is there, you have to just look at the last 2 digit and you have to divide by the cyclicity. Okay, for example, 2 raised to 2025. So last 2 digit of the power is 25. When you divide by the cyclicity, which is 4, you have to look at the remainder. If your remainder is 1, then your answer is your first digit here, 2. If your remainder is 2, then the answer is 4. Remainder is 3, answer is 8. And if your remainder is 0, okay, you never get remainder as 4. Remainder is 0, in that case answer is your last digit, means here it is 6. So this is the important note. Whenever your remainder is 0, always choose the 4th digit in the cycle. Let's start with the example. So question number 1, we have to find out unit digit of 7 to the power 2025. Okay, so the base number is here 7. So what is the cyclicity of 7? Cyclicity of 7, just now we have seen, that is 4. Why it is 4? Because 7 to the power 1, last digit is 7. 7 square, so last digit is 49. Okay, answer is 49, so last digit is 9. But now when you multiply 9 with 7 again, so you will get 9 7s are 63, so last digit you will get next 3. Then you multiply 7 one more time, so 7 3s are 21, so you will get last digit as 1. After that you will multiply 7 again, so 7 into 1 you will get 7. So again it's repeating. So cyclicity is 4, 7, 9, 3 and 1. So only these 4 numbers will repeat. 7, 9, 3, 1. So cyclicity we have 4. So now look at the power. What is the power? 2025. Just focus on the last 2 digit only. Last 2 digit is 25. So divide 25 by the cyclicity, which is 4. So 4 6 are 24. So remainder is what? 1. So remainder is 1, then your answer is what? Your first digit of the cycle, which is 7. Suppose you are getting remainder 2, then your answer is 9. For remainder 3, your answer is 3. And for remainder 0, your answer is 1. So here in this question, we are getting remainder 1. So our answer is the first digit of the cycle, which is 7. Look at the next question. We have to find out the unit digit of 5 to the power 6789 plus 9 to the power 2024. So the first number is 5 to the power 6789. So base number is 5. So we know the result, 5 to the power any number is there, the unit digit is 5 only. Look at the second number, 9 to the power 2024. So the base number is 9, and for 9 we have the result, if 9 to the power even number is there. Okay, so here the number is power in the 2024. Okay, so 2024 last number is even, so that means the full number is even. So whenever 9 to the power even number is there, in that case our unit digit is nothing but 1. If odd number, then unit digit is 9, and for even number the result is unit number is 1. So for the first number our unit digit is 5, then in the middle plus sign we have, so plus. For the second number our unit digit is 1, so 5 plus 1 6. So correct answer for this question is 6. Next question, we have to find out the unit digit of 2 to the power 333, 3 raised to 444 into 4 to the power 555. So start with the first number. Base number is 2. So we know that the cyclicity of 2, which is 4. Now look at the power. The last 2 digit of the power, which is 33. Divide 33 by 4. So we know that 4 8s are 32. So remainder is 1. So if the remainder is 1, in that case our cycle, first number of the cycle, so base number is 2, so in the cycle we are getting 2, 4, 8 and 6. So the first number is 2. So the last digit, unit digit of this 2 raised to 333, which is 2. Now the second number, 3 raised to 444. So the base number is what? 3. So we know that for the base number, for number 3, the cyclicity is 4. Now look at the last 2 digit of the power, which is 44. So if we divide 44 by 4, so 4 ones are 4, then again 4 ones are 4, so remainder is 0. Okay, and we write when we write the cycle of 3, we'll get 3, then 9, then 7, and after that 1. So we are getting remainder as 0. So whenever remainder is 0, your last digit in the cycle, that is unit place. Okay, remainder is 1, then 3, remainder is 2, then 9, remainder is 3, then 7, and remainder is 0, then 1 is a unit digit. So 3 raised to 444, unit digit is 1. Then the third number is 4 to the power 555. So the base number is 4. So in this case we have the unit result we have, whenever 4 to the power odd number is there, in that case our unit digit is nothing but 4 only itself. So for the third number unit digit is 4. So for the first number unit digit is 2, then multiplication is there. For the second number unit digit is 1, multiply by, for the third number unit digit is 4. So if you multiply 2 into 1, 2 into 4, which is 8. So correct answer is here 8. Look at one more question. What is the unit digit of 7 to the power 95 minus 3 to the power 58? So let's calculate first of all 7 to the power 98. What is the unit digit? So our base number is 7. So for 7, cyclicity is 4. So what is the power? 95. So if we divide 95 by 4, 4 2s are 8, 1 will remain. Then 4 3s are 12. So 3 will remain. So remainder is our 3. So in case of remainder 3, the third digit of the cycle, that is our unit digit. Okay, so in the cycle of 7, first number is 7, second number is 7 7s are 49, so 9, then 7 9s are 63, so 3, and after that 1. So the third digit is what? 3. So our unit place is 3 for the first number, minus second number is 3 raised to power 58. So the base number is 3. So 3 also has cyclicity 4. So if we divide the power, which is 58, by 4, so 4 ones are 4, 1 remain, 18, 4 fours are 16, so remainder is 2. So what is the cycle of 3? Cycle of 3 is 3, after that 3 3s are 9, 9 3s are 27, so last digit is 7, and 7 3s are 21, so last digit is 1. So we want the remainder is 2, remainder is 2 means the second digit, that is 9. So our unit digit of the second number is 9. Now don't just subtract here, because 3 minus 9 you will get negative number. Okay, so when you are subtracting, you have to see, for example, you are subtracting, let's say, 3 digit number with another 3 digit number. So here it is 3, here it is 9. So how we are subtracting? 3 minus 9 we cannot subtract, correct? So we are taking here base 10, so 13. So 13 minus 9, 4. Okay, so whenever like this question you will come across, you have to see the subtraction properly, how we are doing the unit digit subtraction. So 13 minus 9, which is 4. So correct answer for this question is 4. Next question. Yeah, factorial one. We have to find out the last digit of 8 to the power 123 factorial. Okay, so suppose you don't know what is a factorial. So let's say 3 factorial. 3 factorial means 3 multiplied by 2 multiplied by 1. Okay, we have to multiply, so that's the answer of factorial. Similarly, 4 factorial. 4 factorial means 4 into 3 into 2 into 1, and so on. Okay, so 8 to the power we have 123 factorial. So first of all, look at the base number is 8. Okay, so cyclicity of 8 is nothing but 4. But now if you look at the power 123 factorial, so 123 factorial is 123 into 122 multiplied by dot dot dot. Okay, till 1 we have to multiply all. So in that, the number 4 itself also will come. So when you divide this full number by 4, so 4 and 4 will get cancelled. Okay, so you just remember this golden rule: any factorial greater than equal to 4 is always divisible by 4. Okay, because suppose let's say 5 factorial. So 5 factorial means what? 5 into 4 into 3 into 2 into 1. So it contains 4 number. It contains the digit 4. So multiplication, all the numbers, one number is there 4. So when you divide by 4, this 4 and 4 will get cancelled. Okay, so any factorial greater than equal to 4 factorial will always but must be divisible by 4. Okay. So this 123 factorial is completely divisible by 4. That means the remainder is here 0. Okay, now base is 8, so what is the cyclicity? 4. So if you write the cycle of 8 is nothing but 8, 4, 2 and 6. Since we are getting remainder as 0, so remainder is 0 means our fourth number on the cycle, that is our unit digit. So the answer for this question is unit digit is 6. Last question. What is the unit digit of the expansion 1 raised to 11, 2 raised to 22, 3 raised to 33 and 4 raised to 44? So let's solve one by one. Now 1 raised to any number, answer is 1. So unit digit for the first number is 1. Then plus 2 raised to 22. So the base number is 2 and the cyclicity of 2 is 4. So if we divide the power, which is 22 by 4, so 4 5s are 20, so remainder is 2. So if the remainder is 2, then the unit digit is 4. Okay, because the cycle we have 2, 4, 6, 8. So the second digit is 4. So our unit place is 4 plus 3 raised to 33. So the number of base is 3 and 3 has also cyclicity 4. So if we divide, power is 33, 33 by 4. So 4 8s are 32. So remainder is 1 here. Okay. So remainder is 1 means the first digit. So the cycle of 3, we have 3, 9, 7 and 1. We want the first digit, that is 3. Remainder is 1, so first digit is 3. So unit digit of this 3 raised to 33, which is 3, plus 4 to the power 44. So 4 is there as a base. So look at the power. Power is even. So whenever 4 is the base number and power is even, in that case, our unit place is nothing but directly 6. For odd it is 4, for even it is 6. So we have to add all these numbers. So 1 plus 4, 5, 5 plus 3, 8, 8 plus 6, 14. So the last date is 4. So unit place is our 4 for this question. So this is a practice question for you. Apply the same cyclicity rule for these two challenge questions. Solve this question and comment your answer in the comment section. Thank you.